Alright, so I thought I would show explicitly that 0 divided by 0 is the same as anything divided by 0. The problem is division by 0, not what the numerator is. And this is kind of similar to the 0 to the 0 power problem, where it's not actually the base that matters. The base doesn't do anything, right? Anything to the 0 power is 1 if we correctly define what exponentiation is, right? So here, what's going to happen, let's start off with our variable x. We're going to set that to 0 on 0. We'll introduce the trick that adding 0 to anything doesn't change it, so we'll add 0 to the numerator. When we factor out the denominator to both sides, we get 0 on 0 plus 0 on 0, which is 2 times 0 on 0. I think pretty clearly we can substitute this for any of these and go any number of times, and pretty quickly we can see that we can get any number times 0 on 0, and it's going to end up equaling the same thing. Right? So say that, let's do the second one just to make it slightly more interesting. So we'll do 0 on 0 plus the quantity 0 plus 0 over 0. Well, that's going to be 3 times 0 on 0, yada yada. We can go forever and get any number times 0 on 0, right? We can rearrange this as any number divided by 0 times 0. So n on 0 times 0 is the same as x. If I want n on 0 by itself, well, we'll divide both sides by 0. So we get x on 0 is n on 0. And now, if we ignore the division by 0, because it's everywhere, and when something is everywhere, we can ignore it, we can see that x is n. N, by definition, is any number that we choose. X is 0 on 0. So 0 on 0 can be any number. Which is something that I established before, but it's just here right now in an equation, right? 0 on 0 can be anything, literally anything. Before I was kind of just piecing stuff together, piecing together this picture that it could be anything. Here it's explicitly in an equation, right? All right. So x is 0 on 0, and I'm dividing that by 0. So when I take a fraction, when you take a fraction and you divide it by something, you multiply the denominators together. So this is the same as 0 on the quantity 0 times 0. Well, 0 times 0 is 0, so we're going to get 0 over 0 equals n over 0. So take these two components, bring them together into a nice, clean, any number divided by 0 is the same as 0 divided by 0. And there you go. And what this is doing, what division by 0 is doing, is it's describing the fact that we have now shifted our operations into a dimension that we cannot access, right? So if we're if we're operating with functions of x, a division by 0 tells us that we're no longer, no component of what we're doing is actually dependent upon x. which means that we've hit a vertical line somewhere, right? And a vertical line is perpendicular to the x-axis, which means it is a completely separate dimension. So a division by zero means that we have gone into a perpendicular dimension, which is why it doesn't seem to act right? Because the way that all of the math that we're familiar with that we can do operates in the dimension that we're working in. Well, a division by zero throws us into a perpendicular dimension where we cannot do any work. We don't have access to it. We can't see anything that's happening there. So all that we can say is that it exists, which is literally what has been demonstrated here, right? 0 on 0 can be anything, and anything on 0 is the same as 0 on 0. So anything on 0 can act like anything. We have no idea, because it is an inaccessible perpendicular dimension to the dimension that we're operating in. And that's it. That's what division by zero is.